So today we are going to talk about the Pythagorean theorem, area and perimeter. Pythagorean theorem is only used for right triangles. And the Pythagorean theorem is listed here below. It says a squared plus b squared equals c squared. The most important thing to remember about this formula is that c is the hypotenuse of the triangle. It is across from the right angle. If you don't have a right angle, you don't use the Pythagorean theorem. Okay. So, we use the Pythagorean theorem in order to find a missing side length. So in number 1, we are finding C. After you know that C is across from the right angle, it's the hypotenuse, A and B do not matter. You can make this one A and this one B, or vice versa. So if we plug into the formula, a squared plus b squared equals c squared, we get 4 squared plus 3 squared equals x squared. 4 squared is 16, 3 squared is 9, combine like terms, and we get 25 equals x squared. However, we don't want x squared, we want x, so to get rid of the square, we have to square root both sides, and we get x is equal to 5. Now what I want you to write down, and this will be helpful and help you save some time in a lot of problems, is that a 3, 4, 5 is a special Pythagorean triple. It works all of the time and gives you even numbers. So as long as the legs of the triangle are 3 and 4, your hypotenuse is 5. Okay, so 3, 4, 5 is a special Pythagorean triple that you would like to memorize. As a matter of fact, any multiple of 3, 4, and 5 would work. So 6, 8, 10, 9, 12, 15, those all work as well. Okay, let's look at number 2. Across from the right angle is your hypotenuse. That is C. After that, it does not matter which one you call A and which one you call B. Plug in, you get 6.3 squared plus x squared equals 15.4 squared. 6.3 squared, you're going to want to type that into your calculator, and you're going to get 39.69. 15.4 squared, you get 237.16. So you can use the squared button, or you could just do 6.3 times 6.3 and 15.4 times 15.4. We're going to subtract 39.69 from both sides, and we get 197.47. But again, we need to square root both sides, and we get x is approximately equal to 14.2. I just rounded to 1 decimal place, and that should be okay. Now, one thing to look at is that your hypotenuse is always going to be the longest side. So if I would have gotten something for x that was longer than 15.4, I need to look at my answer and figure out what I did wrong, because that answer is not correct. Okay. Let's look at number 3. This time they don't give us a triangle, but that's okay. They tell us what B and C are, so that means that we are finding A. So I'm going to say a squared plus the square root of 6 squared equals 4 squared. The units do not matter, don't worry about the yards. So we get a squared plus, now just like when we were solving for x here, the square and the square root canceled. Here they do as well. The square root of 6 squared is just 6 equals 4 squared is 16. Now why does that work? Just as a side note, the square root of 6 squared is the square root of 6 times the square root of 6, which is the square root of 36, and we know that the square root of 36 is 6. But you don't have to write that out every single time. Just know that the square and the square root cancel each other out. Here I'm going to subtract 6 from both sides. I get a squared is 10, and I'm going to square root both sides and get approximately 3.2. Okay, please pause the video. You are responsible for number 4 for tomorrow. Okay, let's look at 5, 6, and 7. Now we are given all three sides in these triangles, but it says determine if the following triangles are right triangles. Now remember, the Pythagorean theorem only works for right triangles, so we're going to test to see if it's correct. Remember that the hypotenuse is the longest, so C has to be the longest side that you are given. So here we're going to have 9 squared plus 12 squared equals 15 squared. Well, 9 squared is 81, 12 squared is 144, 15 squared is 225. Notice I'm not solving anything, I'm just seeing if the left-hand side matches the right-hand side, if it makes a true statement. I get 225 equals 225. That is true, the Pythagorean theorem does work, so this is indeed a right triangle. Now, if you recall, I gave you a Pythagorean triple, 3, 4, 5. This is a multiple of that. If you multiply 3, 4, and 5 by 3, you get 9, 12, 15. All right, number 6. We have 9, 11, and the square root of 115. Well, what is the square root of 115? The square root of 115 is 10.7. Now, I'm not going to plug that in. The only reason why I need to know what that is so that I know that 11 is my longest side. 11 is going to be my C. When I plug in, I'm going to say 9 squared plus the square root of 115 squared equals 11 squared. 9 squared is 81 plus square root of 115 squared, remember those cancel, you just get 115, equals 121. We are testing to see if the left-hand side matches the right-hand side. We get 196 equals 121. That is not true, so this is not a right triangle. Okay, I would like for you to try number 7 for tomorrow. Okay, number 8, the ladder is leaning against a building. The base of the ladder is 5 feet from the bottom of the building and the top of the ladder is 12 feet off the ground. Draw a diagram. So first we have a building. Here's the ground. And they say a ladder is leaning against the building. The base of the ladder is 5 feet from the bottom of the building, and the top of the ladder is 12 feet off of the ground. We want to find how long the ladder is. That's going to be my x. This is a right triangle, so please for tomorrow use the Pythagorean theorem to find how long that ladder is. This is going to give you another Pythagorean triple. It is going to be a 5, 12, something. And that's going to be another Pythagorean triple that you want to memorize. It's going to save you a lot of time. Okay, let's move on to area and perimeter. You guys should be very familiar with this. Area of a rectangle, length times width. So we have 4.5 times 3.2. So we have the area is equal to 14.4. Because it is area, our units are squared, so 14.4 inches squared. Now to find perimeter of any shape, we just add up all of the sides. So perimeter is going to be 4.5 plus 3.2 plus 4.5 plus 3.2. You could also do 2 times length plus 2 times width. You get 15.4 inches. This is just a distance around, so it is not inches squared. The only time you're going to have square units is if you have area equals. Okay, number 2. Area formula for a triangle. 1/2 base times height, or base times height divided by 2. We do know the base, but we don't know the height. However, this is a 3, 4, 5 Pythagorean triple. If you didn't remember that, you would have to do the Pythagorean theorem to find this first. Now we have the base and the height. Half of 4 is 2. times 3 is 6. So the area of this triangle is 6 centimeters squared. Perimeter, add up all the sides, 3 plus 4 plus 5, so you get 12 centimeters. Okay, for a circle, the area formula is pi r squared, and your radius is just from the center to the outside of the circle. It's halfway across, so we have pi times 3 squared. Order of operations says that we need to do our exponents first, so 3 squared is 9, so we have 9 pi. This is exact, but if we went around to the nearest tenth, we would do 9 times pi, or 9 times 3.14, and we get area is approximately equal to 28.3 feet squared. Now circles don't have perimeter, they have circumference, and circumference is just 2 pi r. So 2 times pi times 3. 3 times 2 is 6, so you have 6 pi, which is exact. But if you multiply by pi, or 3.14, you get approximately 18.8 feet. If instead of using 2 pi r, you wanted to use circumference equals pi times diameter, that's okay, because a radius is just a diameter is just 2 radii. Alright, we've got 2 word problems here, and then we're good to go. Anne cuts a hole of radius 4 inches out of a board that is 12 by 14 inches. Okay, so let's start just by drawing a picture. We have a circle with a radius of 4 inches cut out of a board that is 12 by 14. Okay, so if this is a hole, this is where your board remains. The circle is no longer there. It says, what is the area of the remaining board to the nearest inch? Okay, so to find the area of the board, we're going to take the area of the rectangle and subtract out the area of the circle. So we're going to do area equals length times width, and then we're going to do area equals pi r squared. Once you know those two areas, you can subtract them to find the area of the hole. Okay. So for tomorrow, I would like you to have this answer for me. So find the area of the rectangle, find the area of the circle. If you subtract those, then you get the area of the remaining board. We will talk about the percent of the area that's remaining in class tomorrow. Okay, number 5, last one. The length of a rectangle is twice the width. Again, we're going to start by a picture. We don't know what the width is, so let's call it x. And we don't know what the length is, but we do know that it's twice the width, so we're going to call this 2x. And it says we're going to deal with area here. So area is just length times width. So 2x times x, we know that x times x is x squared, so this area is 2x squared. It says if the length and width are doubled, the area of the original rectangle is what percent of the area of the larger rectangle? So let's double this length, which means multiply it by 2, that's 4x. And if we double this, that's 2x. So the area of the bigger rectangle would be 4x times 2x, so 8x squared. So what it's asking is, what percent is the area of the original rectangle compared to the bigger rectangle? So to find a percent, we just divide 2x squared divided by 8x squared. The x squareds are going to cancel, and we just have 2 over 8. We know that that is equivalent to 1/4, and 1/4 as a percentage is just 25%.